Hello student, welcome to our first lesson. In this lesson, we are going to discuss electric fields and electric field pattern. Now, we start with the introduction. If you can recall in electrostatic 1, which is a topic in Form 1, we found that charged bodies like plastic pens are able to attract light particles like pieces of paper. Actually, we did this activity where we rubbed our biro pen or our plastic ruler against our sweater or our hair, and then we brought it closer to the pieces of paper, and we found that that plastic pen was attracting the paper. And we said that in our conclusion that this plastic pen, by rubbing it gains what we call the static charges, and those static charges were the ones that were responsible in the attraction of papers. So in other words, we can say that whenever there is charge, there is that force of attraction, and whenever there is attraction, of course, there is repulsion. Now, the force of attraction or repulsion is strongest when the charged bodies are close to the object and diminish as the bodies move further away. Coming back to the plastic pen, if you move the plastic pen far away from the pieces of paper, you'll find that it may not be able to attract. But if you bring it closer to the pieces of paper, you find that it will attract almost every piece of paper, which implies that the distance between the particles and the charged bodies matters. So if the charged bodies are close to the particles, you find that that force of attraction is stronger, and also the force of repulsion is also stronger. Now, this shows that the charged body exerts its influence only within a certain region. At beyond that certain region, you will find that there will be no influence. That attraction and repulsion will not be felt if the distance is large. Then from there, using those examples, we come to the definition of electric field. And now this electric field refers to the region where a charged body experiences a force of attraction or repulsion. That region within that charged body where the influence of attraction and repulsion is felt is what we call the electric field. Then we need to know the direction of an electric field. Now, a direction of the electric field at a particular point is defined as the direction in which a unit positive charge is free to move when placed at that particular point. So if you place a positive charge, the direction in which it is free to move is what we call the direction of the electric field. So we have the charged body here. Right? We have the charged body here. Then we have the force. We have this one is positively charged and this one is negatively charged. We have the electric field is towards this one, and the electric field in this one is towards that one. Because now if you look at the body here, which is positive, this body will move towards the direction opposite because it can't move to the positive. Then you have the positive body here. This is positive. So if it is placed here, it will move towards this direction because it will be attracted by the negative. So this is now the direction of the electric field. And this is the direction of the electric field. In other words, we always say that the direction of the electric field is always from the positively charged particle towards the negatively charged particles, as we are going to see when we talk of electric field patterns. Now from there, we can move to electric line of force. Now this is the path along which a unit positive charge would tend to move in the electric field. Remember, we have seen that the direction of electric field is the direction in which a positive charge would move if it is free to do so. Now that path along which that unit uses is now what we call the electric line of force. Then we move to the properties of electric field lines. One, we have that these lines, they start at 90 degrees from the positive charge and end at 90 degrees on the negative charge. So from here we can say that the electric field lines always start from the positive and add to the negative. And because we are talking of 90 degrees, it means that it is perpendicular to that particular point. Then they do not cross each other. They tend to contract or expand so that they never intersect each other. In other words, we are saying that as they move, you find that they are either contracting, coming closer, or expanding, making sure that they don't cross one another. Then we have that unlike charges will always repel. Unlike charges will always attract, while like charges will repel. That one is the basic law of electrostatic that was studied in Form 1. Then when you see the parallel field lines, then you'll know that that field is uniform. But if they are widely spaced, then that field is weak. But where they are closely arranged, then we have a strong field. From there, using these properties, we can be able to draw electric field patterns. And first of all, we can start when we have an isolated positive charge point. When you have an isolated, it means that it is all alone. You will find that the electric field lines, and because it is positively charged, the positives or the fields will be pointing away from the positive charge, and they will go around the charged bodies. So this is now the electric field pattern of a positively point charge. You can be able to see that. Then we can consider isolated negative charge. When you have this again, the charges will, or the lines will be coming towards the negative charge. So the arrows will be pointing inwards like this. You see, because now we are using the first property that this one, they always come from the positive and they head towards the negative. And again, whenever they are touching this positive, it is perpendicular, or it is making an angle of 90. So this one is towards, this one is away. Then we can move to another pattern. We have two equal positive charges. Remember, we have said that like charges repel and like charges attract. In our case here, we have now the like charges here. So we expect a repulsion here. So that is why now the field lines are moving away. But remember, the arrows are pointing away from the positive charge, showing that the positive charge would move towards that direction. So in here, the value of X, or the point X, is what we call the neutral charge. And it is as a result of cancelling out of these two electric field. Remember, we have the electric field here and electric field here. And then the resultant here will be 0 because of the repulsion. Then we have two unlike charge point. Remember, unlike charges attract. So in our case here, we have a positive and a negative. So again, you can see that there is attraction between the two charged bodies. But remember, the arrows should point from the positive towards the negative. So in here, you can see that these arrows are pointing towards the negative, and in here they are pointing away from the positive. So that shows that the field lines always come from the positive towards the negative. Then we have two unequal positive charge. As you can see here, they are unequal, meaning that this part is much stronger, and the stronger field is indicated by the number of field lines. As you can see, as we consider 1, 2, 3 here we are considering 1, 2, 3, 4, showing that this one is more stronger than this one. Again, you'll find we have the region X, which is a neutral point, because again there is repulsion. Then we have positive point charge and a negative electrode. When we talk of a negative electrode, it is a plate that is negatively charged. So we have it like this one. We have a positive, and then we have a plate that is negatively charged. Because the two are unlike charges, there will be attraction. And therefore, that's why we are having this kind of field lines. Again, note the direction of arrows. After that, we have negative point charge and a positive electrode. Again, there is attraction, but note the direction of arrows. They must be coming from the positively charged body. In our case here, the plate is the one that is positively charged, and then they are towards the negative. Then we have charged negative electrode. As you consider the two charged electrode, there will be repulsion, but note the direction of arrows. Remember, if you don't indicate the arrows, then those will not be electric field lines. For us to draw electric field lines, you must ensure that the arrows are indicated here. After that, we have the charged positive electrode. Again, there is a repulsion, but note the direction of the arrows. They are pointing away, but this one they are towards, so that way we are able to know which one is positive and which one is negative. Then we have two parallel metal plates having opposite charge and placed close together. So we have it here. They are placed close together and they are having opposite charges. So there is attraction. And in this case, when we talk of the attraction, then it means that the field lines will join the two plates, and then the arrows will point from positive towards the negative. From there, we have the assignment. So the assignment is just testing what we have just covered. So make sure that you practice a lot. If you can't recall, just go and listen again and then come and attempt the assignment. This assignment is just testing whether you have understood. So thank you, and let us meet in our next lesson.